collaborates with Philip Beasley for Living Architecture Systems Group. Aya Rashid is a graduate of the Architectural Association Design Research Laboratory, the AADRL. She has been teaching at the American University in Cairo and is also now teaching in Dubai. And finally, Sarah Pajesk is a graduate both of SIARC and of the Architectural Association MTech program. And Sarah, many of you will know, is teaching at FIU at the moment. We have a remarkable group of candidates. I will just mention that last year we also had the first episode of Doctor Who, and if you do a screen capture, you can get the link to the previous session where Sumin Ham, a professor at SIARC, presented her work. Philippe Morel, who teaches both at UCL Bartlett and also at Paris Malaquais, also presented his work. And then finally, Marina Rodriguez das Neves, who's been teaching in the University of La Plata and also at FIU. She also presented her work. And I would say that we have actually a remarkable group of individuals. They include those who've been working for Zaha Hadid Architects, for OMA, for UN Studio, for practices such as that. We include graduates of the Architectural Association, of SIARC, of Tsinghua University, of MIT, of Harvard, and many other interesting schools. And we also include professors who've been teaching, as I mentioned, at UCL Bartlett, also at the Architectural Association, at SIARC, at Hong Kong U, American University of Cairo, and so on. Many of the sessions that we included, we have held, are uploaded onto our YouTube library. If you just go listed at the bottom there, and you can go and see other sessions that we've held. These have included sessions with people like Wolf Pricks and other figures and address particularly the theory of artificial intelligence and other issues. In today's session, we will start off with Aya Rashid, who's currently in Dubai, where it's just gone 10 o'clock. And then we'll move on to Matt Gorbet, and then to Wan Yu He, and we'll end up with Sarah Pajesk. We will try and keep this to within the hour, or shortly, or slightly over the hour, and we will have a time maybe for a few questions at the very end. But I would like to welcome, first of all, Aya Rashid to share her screen and to make a presentation of the kind of her work. Aya, welcome.
Thank you. Thank you so much, Neil. And thank you everyone for the invitation. It's truly an honor to be with you all today. Hello, everyone. My name is Aya Rashid. I'm going to be giving you just a quick background about myself first. So I graduated in 2014 from the architecture engineering program at AUC. And then later on, I moved on to do my master's at the AADRL program, as Neil mentioned, which was truly a remarkable, eye-opening experience for me. Shortly after that, I moved back to Dubai, and I recently started my own practice with a business partner called Shift Space Design and Research, as well as teaching at different universities here. And last year, I joined the FIU DDes program to continue my line of research and continue working on the things that I'm truly passionate about. So just to give you again a brief introduction, I'd like to think of my work positioned at the intersection of architecture, technology, design research, art, as well as robotics. So I like to think of myself as a kind of an anti-disciplinary kind of person who likes to explore new realms that are not fixated or basically confined by a certain field or another. And I think a lot of architects nowadays kind of are moving beyond the conventional definitions of architecture and kind of exploring new ways of combining different disciplines together. First of all, I would like to introduce some of the work and research that I've done during my time at the Architecture Association, the DRL program. My research alongside my group was titled SlinkyBot. SlinkyBot basically was a behavioral design system that is an autonomous, self-assembling, and self-aware system. It aimed to provide an alternative approach for living that extends on the ideas of materiality and geometrically elastic, endless, and ever-evolving architecture. So it was really important for our team to kind of view these Slinky bots as companions in the house that offer some kind of emotive support, as well as having their own independent life cycles that are symbiotically intertwined with the human life cycle, basically creating an environment that grows and adapts with its users. So again, trying to move beyond the static definitions of architecture. As a self-assembling system, there were certain criteria that we had to keep in mind, which is basically that our system was unit-based. It was also time-based. So as time progresses, the units start basically gaining capabilities of communicating with one another. There was a sense of mobility and autonomy within the units. And the most important thing was the way they would self-organize and kind of self-assemble together. We looked at a lot of references in nature, including the intelligence found in ant colonies and swarm intelligence, to kind of learn from how complexity can be built up from systems that include units on their own, might not have the kind of complexity or intelligence on their own, but together working collaboratively can basically lead to new possibilities. So our system, the way we kind of approached it is we approached it in a polyscalar way. So we thought about it in a unit kind of based system, as well as a more taxonomy based system, as well as a kind of a reconfigurable organizational system. So it was important for us to tackle these different scales within our design system. Starting off with the unit, it was important for us to have some kind of a dual system or a dual unit that has some kind of a compact state as well as an extended state. Each state offered different functionalities and different benefits. The compact one was seen as a more structural and a more mobile state, whereas the extendable one offered more transparency and offered different kinds of choreographical movements. So in our initial kind of prototypes, we looked at creating this compact state with a monowheel in between that has the ability to move and turn the unit itself, as well as we looked at in ways of extending this unit. We quickly realized that basically basing our unit on purely hard materials was something that is not really human friendly, especially that we thought about our system as being something that is an add-on system to an existing household. So we thought about it as a kind of interior add-on system that is in direct contact with humans. So we quickly needed to think of ways to make it softer and make it a little bit more human-centric. So we explored some soft muscles that we tried different kinds of materials to basically experiment with. These soft muscles would allow the unit to have certain choreographed movements, as well as allow it to be able to extend and return back to its compact state. After several material explorations, we reached the decision to go with the polyurethane muscle material that allowed us minimum and lightweight material, as well as a kind of material that also was able to have the flexibility and the strength to push the unit outwards and inwards. So this is kind of a diagram that represents the overall components within the unit. So this is half a unit showing the hard shell as well as the soft silicon muscles that were embedded on this hard 3D printed shell, and the extendable soft muscles that were integrated within the shell. These are some of the prototypes that we looked at and that we kind of reached by the end of our research, that showed us some kind of extendability and some kind of choreographed movements. Of course, as we experimented and created several prototypes, the scale quickly started to increase in size, which is something that was a bit of a limitation that we needed to also bear in mind. It was important for us that our Slinky bot had some kind of communication with other Slinky bots so that they were able to perform some collective behaviors, such as collective mobility. It was not important for us that every Slinky bot had the kind of decision-making to decide where the unit needs to go. It was easier for us to think of it in a way as leader units and as well as following units, which basically responded to what the leaders of their clusters dictated to them. Our units, it was important also for our units to have some kind of awareness of their environment and surrounding. Since it was an add-on system to existing households, it needed to be able to scan the environment and recognize areas where it would be able to, for example, climb upon or basically extend or dangle from. These are some experimentations that we did in terms of inflating and extending the units on a more collective way rather than just a unit kind of experimentation. This collective behavior would lead us to basically the different kinds of functionalities that the system would be able to do. So beyond recognizing the human and responding to their ergonomics, we imagined different functional landscapes that could be created with these extendables as they work together in a collective way. As well as performing in kind of a responsive lighting system, the units would be able to recognize the humans passing by and respond in a way to light up the area as needed or according to the occupancy of different spaces. The way we simulated some of these organizations were based on simple coding rules. Some of these coding rules had linear relationships, others focused on a more radial one. And just utilizing these basic logical concepts, we were able to start creating different taxonomies and start giving them different functions or where they would fit best in different ways around the household. So we created taxonomies that would basically try to respond to gravity, and these were taxonomies that were more tailored to ceiling functionalities, such as lighting behavior or extendable structures from the ceiling. Other taxonomies focused more on ground-up behavior, creating the functional landscapes that I have shown earlier in the slides. So again, in our system and the way we try to simulate this using coding is the units would basically try to find the humans as certain physical boundaries and try to expand and alter the space according to the occupancy and according to the needs around the users of the space. These are some visualizations of different kind of, again, states that are time-based according to the time of the day and as well as according to the occupancies within the household. So this basically wraps up a bit of the research that I've done during my my experience at the DRL. I would like to kind of move in a chronological order, and soon after my experience at the AA, I came back from London to Dubai, and shortly after that, I've started my own design startup with my business partner, Jumana, called Shift Space Design and Research. And basically in our studio, we try to integrate some of these computational design experience that we had and research, and try to find applicable ways to realize them, that they are also culturally sensitive to the region that we are based in and to the backgrounds that we come from as well. So this proposal is called Plush. It was one of our design proposals that recently was awarded. Basically, this proposal was for a pavilion design that was interactive and as well as responsive to different kinds of conditions. So the design of the space itself is quite straightforward. The thing that we really try to focus on is these kinetic, the mix between static and kinetic panels, which would respond in different ways. This was also a collaboration with an institution in the UAE called BIA, which is basically a facility that sorts out recycled material. So we thought about integrating this recycled material within our design of the pavilion. And basically, we ended up experimenting with a lot of different materials. And we thought of integrating HDPE and creating different panels out of HDPE, which we found was quite durable, as well as stiff enough to handle being used as certain panels, as well as being light enough to be mobile and to easily move and be kinetic. So these are some of the experiments we did with different mixtures of transparencies as well as colors of HDPE mixed together to again showcase the different aesthetics that we could reach with recycled material. We created kind of a prototype to showcase the kinetic aspect of the pavilion and how it would open up and close. So the way we imagined it is the pavilion would have two scenarios. One scenario that is more based on human interactions or playfulness that would basically invite users to come into the pavilion and see whatever exhibitions that is hosted within it. The second kind of scenario responded more to the pandemic, and it was more of an occupancy related reaction. So as the occupancy of the space increases or as it reaches its limit, all the panels kind of open up to have better ventilation and to act as a warning sign that occupancy has been reached, so that certain protocols can be followed. So this was just a quick proposal of one of our ideas that we've been working on. I think our main aim for our studio is to integrate, again, technology, design, architecture, as well as be sensitive to different cultural and regional aspects in our design. And I think at the end of the day, that's truly what gives us our edge. So what's next? For me, after basically going through a lot of my research experience during my master's program at the AA and some of my practice experience in different corporations, as well as my own startup, and being interested personally in interactive behavioral systems, I wanted to continue my research in these kinds of systems, but move beyond the fact that humans are still seen as physical boundaries to a lot of these interactive smart systems, and trying to integrate a certain kind of emotional intelligence that would result in a more sensitive, productive, and machine-human interactions and different kinds of experiences within these responsive environments. So for my DDes at FIU, my general goal, and this is still a work in progress, of course, I would like to aim to create a relationship between materials, form, and behavioral interactive systems to generate a more empathetic relationship between humans and their environment, to explore the potential of how to simulate empathy and blur the harsh boundaries between machine-human ecologies and develop a state of harmonious coexistence and companionship. So basically, again, moving beyond humans being seen as mere physical boundaries and creating systems that truly see us as humans and have some sense of empathy and understanding of our different states. So just to break it down really simply, I aim to create some framework or a system that is behavioral and empathetic, learning from nature and biomimicry to set up this behavioral framework. Nature is always our best teacher, and this is something that we are always inspired from, as well as integrating a sense of emotional intelligence to add a layer of effective computing to these design systems. And just to basically wrap it up, so why emotional intelligence and what can we learn from human emotiveness, and why integrate effective capabilities in computational agents? I mean, some of us might think that computational agents, their main requirement is to be, of course, functional, and that is true, but it's also, the argument can be made that with them having some of these effective capabilities, they can be more functional and more rational in their decision making, and have a better understanding of us and have more human-like attention and perception to the occupants around, to the users around, and eventually learn to adjust their behavior and interaction to have a more human-friendly and a more basically a system that understands and is able to determine salience and as well as valence. So basically, this is kind of the ultimate general goal. As I mentioned, this is still a work in progress, and I am excited to basically push this forward and see what comes out of it. So thank you so much for listening, and it's truly an honor to be with you all today.
Thank you, Aya. That was very interesting work. Let's move from Dubai to Canada, to the colder climes of Canada, and welcome Matt Gorbe. Matt, as I mentioned, is a graduate at MIT Media Lab, and he's been working with Philip Beasley on his living architecture systems. Matt, welcome.
Thank you, Neil. It's also an honor to be here and really happy to present today. I think thematically, I'll also be following Aya fairly closely, so that's kind of nice. So the DDes program here, I think I have something in front of my share. Let me just move this. Sorry. The DDes program is billed as a post-professional program, and I think for me that actually is one of the things that really struck me, and I have basically had a career already in some of the work. So I'm going to start out by talking a little bit about my background and some of the projects I've done leading up until now, and then I'll tell you what I've been working on recently and where I want to go from there with the DDes. But going back to the 90s, as Neil said, I was a student at the MIT Media Lab in the Tangible Media Group, and spent most of my undergrad there. Even though I did an architecture undergraduate degree, most of my time was spent in the Media Lab playing with what was called tangible media, so the intersection of physical computing and data, et cetera, to develop new interfaces. Working from there, I moved, when I left the Media Lab, I moved to California and worked at the Palo Alto Research Center, Xerox PARC, and was there until about 2000 with a research group also exploring new genres of how do physical and digital come together. And one of the things that really struck me at that time was that there were some really exciting and interesting projects going on in research and in, in experiments. But there was really not a lot of this out in the real world. And that sort of lit a fire for me, and I got a bit itchy. And so in 2000, I moved back to Canada and started a design practice with my partner, Susan. And for about 20 years now, so for a couple of decades, we have been doing experiential art and design installations, as well as teaching and some other pieces of it on experience design and on futures thinking and on design thinking. But it had me, wearing a hard hat a lot and out in the field and kind of making things. So I'll tell you quickly just about 3 of those things, and then I'll talk a bit more about the more recent work. So in 2007, the Royal Ontario Museum in Canada commissioned a new giant expansion by Daniel Libeskind, as you can tell probably by looking at it. And they raised a lot of money to do that. And they commissioned us to create a donor recognition monument for the donors of this fundraising, which was kind of the largest capital project in Canada at the time. Actually, they raised an awful lot of money to do that building. And so what we ended up creating for them was an obelisk that sits in between the old building and the new building and has features of both. But the key feature of it is that it is active and has some life to it, in that when you bring your hands to the stone surface of the obelisk, which is carved with thousands of names, it glows gently from the inside to kind of acknowledge your presence. And in doing so, what we wanted to do was really create something that was both a lasting recognition of the people who had given to this building, but also became something attractive and playful for people in the world. It wasn't just a static object. And balancing those two things is part of the kind of work we were trying to do by bringing the technology in a way that it really is actually all about the human experience, and the technology gets out of the way. So there's laser cutting, and there was LEDs, and there's capacitive sensing and all kinds of stuff, but really it's about that experience with that piece. Similarly, this project was around the same time. It was for a retail store that was a very, very busy, very, very crowded retail store. And the owners there wanted a feature, a little bit like a fountain, something in the store that could kind of slow people down and make them more contemplative. And the theme of the store, it was called Galileo for Galileo. So the theme was about exploration and light and discovery. What we created was this kind of fountain surface that combines the physicality of stones and Corten steel and reclaimed wood with augmentation by projecting light that travels and follows and searches and lets you kind of take a breath and just sort of play in this space. And again, it's not about the technology. It's not about the magic of what it can do so much as it's about how that makes you feel or how one interacts with it. So the themes through my work have all been about this sort of human experience and how technology and physicality can come together to really augment or enhance that. The third piece I'll show is just the biggest, sort of most architectural piece that we did during that time. It's a piece called Solar Collector. It's also got an environmental theme. It was commissioned for the first platinum LEED building that was a municipal building in Canada. And they really wanted something that was large scale, dynamic, but also had something to do with environment or solar power. And thinking through that brief, we came to create this piece, which consists of 12 aluminum shafts that are sort of arranged, and they're arranged kind of mathematically so that they follow the sun through the sun's cycles through a year as it moves higher and lower in the sky. Of course, we're in Canada, so in the wintertime, it's much lower to the horizon. And that creates this extraordinary shape, which is very dynamic as you move past it. But then on each of the shafts, there is a custom solar panel that collects energy during the day, and also custom lighting that we created that releases the energy at night in patterns. Then there's a website that people could go to. So it is interactive, and people could put a little bit of themselves into it by going to this site and exploring the patterns and playing and composing different kinds of light patterns or light shows for that night. And then every night it would play a different pattern or a different set of patterns from the what it had collected through through the site. So we really think of it as a collaboration between the sun and the community, between people and the sun. So that's the kind of work that I was doing for 15 to 20 years. And slowly, as we got to sort of about 2018, I found myself working more and more with a group of people called the Living Architecture Systems Group. And I ended up, up on ladders again, but here working more in a collaboration with others and with dynamics and a sort of a form factor and a form language that was created by Philip Beasley, who's a professor at the University of Waterloo and an architect and a sculptor internationally known. And he had assembled a group of researchers around the world, people in everything from education and psychology and philosophy, but also architects, designers, artists, to create something called living architecture and explore these questions about can architecture itself integrate living functions? Can it engage with visitors and sort of enhance the human experience? So it operates on a lot of different levels. There's the physicality of the architecture, very, very intricate and carefully constructed forms that are structurally really boundary pushing, but also extraordinarily light and force shedding. So they respond and they react to their environment in terms of the structure, but also embedded within them some chemistry and chemicals that do different kinds of things in terms of the light. We call them protocells, and it's sort of like the prototypes of life, and really interesting new manufacturing techniques to build these physical structures. In addition, the pieces have within them a lot of digital technology that is embedded as basically the nervous system throughout the pieces. And that's the part that I was working the most on, that and the idea, again, of the human interaction or human intersection with these kind of immersive environments. So as part of this research, there are 3 permanent or long-term test beds right now installed, and more actually in the works. One in Canada here, one in Bloomington, Indiana at the Indiana University, and one in Berlin that they're running right now. And in addition to being an immersive environment that you can move through, they also respond to the users or to the visitors. And this was a lot of what I was doing and what I am doing with this community, is starting to think through kind of what does it mean for an environment to be able to sense people and to respond to people, and how should those responses work, and what kind of controls happen. And sort of this work happens at a lot of different levels. It happens both in sort of the practical of how do we put all of this together, but also kind of the conceptual of how do we architect those different parts of a big complex system like this to make it eventually, it comes back again to that interaction, to that experience design for people. How do people respond to this, and how does it create, generate, or support emotion? How does it challenge? How does it enhance? How does it surprise? How does it delight? All of those kinds of questions. So I move back and forth between the very, very technical sort of technicality of the architecture of the system in order to make it resilient and robust and extensible and scalable, but also the logic of the system and the system's behavior. How does it know how should it know what to do at any given moment, et cetera. And in working through that, I've developed a number of tools, and it's in making those tools and in trying to think through how are we going to, as designers, think about these spaces, that I really started to think about it a little bit more long-term, and to think through this notion that we really need ways as designers to access this emerging field, or this emerging discipline of responsive, expressive artifacts and objects that are around us. Most of the work that I've showed so far is very custom built and custom made, and you need a certain kind of expertise to play in that world. But as designers, I think as these capabilities are emerging, and especially as we see new materials that are available that can change colors, change shape, and robotics that are coming online, and AI processing in the background, how does all of this come together into a discipline that people can actually work within to express themselves and to make what they want to make? So as future architects, as future industrial designers, as future designers, how do we go from just teaching about color, materials, form, and the sort of standard design education to include time and behavior and interaction and experience design and really the psychology and the awareness that it will take? So that's what I'm most focused on in my DDes, and that's kind of where I'm going, both thinking about conceptual frameworks, but also thinking about practical tools that can be built, and what are the principles that should be applied in building those tools and in starting to take this forward into the future. I have a couple more minutes. I'm just going to show you a couple of pictures of very recent projects that were done. Both of these were done during the pandemic, so both of them were installed remotely. This was in Venice at the Biennale of Architecture in 2021, a large-scale interactive space we could walk through with a projected computer-generated world also integrated with it. And this, again, making these boundaries where you cross between the physical and the digital is a really interesting aspect of bringing a space to life and creating living architecture. And this also had a 48-channel surround sound composition that was dynamic and 3D spatialized, built with custom-made speakers. And I'll just quickly show a couple of pictures of one other project that was done last month, a couple months ago in Brittany, France. And this was a private commission, but it shows a little bit, again, the way the structure works, both in terms of a scaffolding that is then dressed. And then here's me working from Canada on a project in France to give it sort of a brain and to try to give it some kind of active behavior responsiveness that will be compelling, that will be challenging, that will be engaging for people within it. And I think long-term, the vision is if we are able to do this, a lot like what I was talking about, how do we create systems and buildings and built environments and objects and artifacts that are empathetic, that do know us as humans and that can respond to us. So in long term, in the long arc, that's the goal, and that's where I'm going with it. There's a lot more information at these links if you want to follow them, and I'll stop there so we can let others carry on.
Thanks, Matt. That was exquisite. It's always good to see the work of Philip Bezier. Philip, I should say, came down to FIU to give a lecture not so long ago from Canada. And of course, Canadians do like to come to Miami because the weather is so beautiful this time of the year, and it's kind of cold in Canada. I'm going to share my screen now, and I'm going to show Wanyu He is in Shenzhen, China, where it's 2 o'clock in the morning. So I've got a recording of her presentation, and Wanyu, I should mention again, is the CEO of XCool, probably the leading software developer for AI for architecture in the world. She has 200 employees there, and there are 100,000 users of the XCool software. XCool means ex-Koolhaas. She used to work for Rem Koolhaas. So this is Wanyu. Oh, hold on a second. Let me just stop it. I wanted to go and make sure I, share my sound. Okay, I have. Yeah, good.
Hello everyone, this is the Wanyu from XCool. I'm also DDes from FIU. Today I'm going to present what we are doing as XCool in Shenzhen. What we're doing is empowering design with AI. And how about AI usage or AI applications in the architectural industry? Basically, we have saw a lot of examples nowadays using the GAN and the image data to generate new images of the architecture. And those kind of image usage can inspiring us to get some new ideas, and it can be enormously be generated and expand our imagination. As you can see on the screen right now is the results be generated by our AI. And this one, we did it in 17th April of 2019, basically 3 years ago. And we found out that those images are fun, and some of those can be highly resolution. But the issue is, even though some of the images looks pretty good, like the ones on the left side, some modern design, villas, and the right side are the live views. But the thing is, those images can not be used as architect. It can just be idea inspiring stuff, let's say. So we're thinking nowadays we are just using the AI as a application. Is that so? Or we can really develop further? Actually, we had this thought like 3 or even 5 years ago. So we started looking for deeper usage of the AI or artificial intelligence. So as the images we saw previously are just images we generated by a game, but how about graphics? We're not dealing with images as architect, we're mostly dealing with graphics. So how about graphics? We did this one also in end of 2019 as part of the Shenzhen Biennale with the creator of Kalorati in Shenzhen. And you can see we can draw basically everything on the left side, even something nonsense. But the right side, the machine can generate some really look fine images. So in this project, we bound the graphic and the image together. So this one opens as a door that we can try to link the two different, let's say, languages together. And the result of this exhibition is quite a success, and we found it's very popular by the kids. And it will really open some minds for them to find out what architects can do with the AI. But how about 3D? Not just in 2D as the graphics and also with the images. So we are thinking we should use other models to do it. So basically we still need the game to generate, but there's other things we need to do. Firstly, you have to connect data and also train with the models. There's a big, sorry, let me move this away. There is a big jump from the GAN towards this model, but sorry, I cannot really explain too many details of this one because this is what we do with our team. But you can see the result. You can draw anything on the map or even on the screen, and you can get a result with 3D modeling. It's not just the 2D graphic, it's also in 3D. And this thing is pretty interesting. We developed a long exist city web on website, and you can just draw anything you want and can generate those results. So if you can see the screen right now and go to this coolsketch.xcool.ai, you will find out you jump into this website. So any one of you at any moment, you can get in and try something out. For instance, this one is a long exist city, and this is we call impossible building is the one the kids drawing. And this is a unusual landscape. Let's try it with this one. You can draw something on the side, anything. And you can also do some, just sketches and click the generate. And it will generate this for you. You see, this is a 2D image be generated by the upper drawing tool. And on the right side is the 3D model. And this model, you can rotating it and really look at it. It's with the landscape and the building. It's very interesting to try your idea out. And Yeah, and this is basically, yeah, this one. But it's very interesting. Yeah, you can try it out. And furthermore, we're thinking, how about the differences between man and machine? We share some similar mechanism of learning. For instance, we get information and we process it, and we get our biological recognition, and we express it as an emotion or actions. And similar as the machine, it uses the data analysis and to use the neural networks, deep learning, and generate new things, and we get outputs. The only difference is the AI here is very specific in a quite narrow field, let's say. For instance, the model we're training, and it can just be used in this data sets, and there are also referenced or referred fields. It cannot jump from something it doesn't be trained before. So if you want to build a general AI, it's very difficult because you have to learn a lot of things. Like AlphaGo is just the master of goals, but nowadays they are developing. I mean, DeepMind, they're developing different alpha series, like alpha in medical or in mathematics. Yeah, everything. Meaning you have to train in different ways or different models, different data sets. And here we are in the architectural industry. So we're thinking, how about to really collaborate the AI and us architects together? So we are thinking it will be good to collaborate the man and machine. So how about real tools, not just the toys we saw before? I mean, we saw it previously as the webs. So we get started with the real tools. This we call the XUrban Tool. And you can see it's already a very sophisticated tool. You can upload your CAD file, you can input some data, and generate some, like here you can draw your X, and you get your urban design, basically. And this urban design model is not just a image or just a model on the web. You can download it, and you can also re-render it, and also you can require the program or this we call tool to analyze some basic information for you. For instance, this is the showing the closest to the water, and also some for instance, we can zoom in this area. You can see the different programs and where's the core, and where's are the landscapes, etc. So it can be used in a lot of different scenarios, and also the machine can generate different outcomes. You can see here there are 3 outcomes or even more, and you can download it as the Rhino file, and you open it in Rhino. You can get all those different layers, and also the facades be done. So this is a very already architect-friendly tool, right? But we also took it further. We're not satisfied with that one. So we developed a powerful tool. We call it a master planner. And this one is really the best tool we ever had with the master plan scale. Similarly, you can upload your CAD file, even the models, and you input your let's say preset parameters, and the machine generate those results for you. See here, quite enormous of possibilities. And you can just select what you want, or you can just try to get your hands on You see, in this area, I want the low rise, that area, I want the high rise, or I can just change some areas. And also you can do the editing as you always do in the CAD or some other model making tools. But here, our online platform we call XCool Design Cloud, it will really shows you if this one fit for the local regulation, and what is the distance between the different towers, how many meters you can still move under the regulation. So it's not just drawings or drawing tools. You are actually talking with the machine. The machine is watching you, saying, okay, this is red, means it's not obey. It is not obey the rules. You have to change it. And further, we also have the not just for residential, but also here you can see we can just also generate the commercial on the roads very easily. And this is a very smart way to doing the sound regulation checking. It's just the real time. You just move any building, it will shows you what's the regulation, the sound radiation, and if it's fit for the local rules. And it's also showing you which building or which facade, even which unit is not meet the regulation. So nowadays those regulations are more all based on Chinese regulations basically. But I understand some countries or cities, they're sharing the similar rules. And also this one, we got some very interesting, like say this one is sharing functions. You can share with the QR code, and on your mobile you can see it and you can comment it, and everyone can see your comments. It's very interesting. And we can also visualize the results. For instance, we can generate the facade as previously you saw here, and this is the colors. It show different information. Where are the villas, where are the high rise, where are the unit A, where the unit B, and which floor is not for residential, is for the fire escape, etc. So all the information, all the data, this is all the data in the area, everything about the building itself, but the space is already be generated with the model already. So you don't have to like calculate the results after you're doing the design. This is a really a big development of a design tool. So basically we redesigned the design tool and we call this one XCool Design Cloud. And we are not just satisfying with the master planning scale, so we jump into the building scale and I call it Building Creator. And you can see here the Building Creator, sorry, it's in Chinese right now, but you can see here we have a similar logic. Firstly, you can upload what you had already, and we can do the CAD like recognition, discrimination, etc. And you can upload your CAD file onto a cloud file, and it can be stored anywhere you want. And we already have 1,000 of units there. You can use it. And this one's really AI interesting. You can sketch any block, and we'll generate the unit for you. And we're guessing which unit you want on the bottom. You see, when you add some elements in, it will just generate a new unit, and it will automatically generate the axis, also the basic structure of this unit or this floor plan, and the core with the staircases. Even you move the walls, it will automatically fit for it. And also the interior doors, windows can be generated based on the regulations of the local codes. And also it can generate the furnitures. I think this one is really saves a lot of time, because every time when we showing or design layout you have to fit in the furnitures. And also MAPs can be generated as well. Also in 3D, you can see very clearly where are the different pipes. And all those, this platform is online. Let me explain again. The entire XCool design cloud is online, but you can use your very familiar shortcuts, like you get used to in CAD or Rhino, and you can just edit everything you want. And here we also have the 3D mode, and this one is the rule checking. For instance, you move to somewhere else, it will tell you, no, you cannot put it here, it's red. It's very fun. And also for the area calculation, it's automatically. And you can see all the different area checking, even with the different regulations. For instance, the balcony here only counts for half the area. It's all be there. And also you can do the regulation checking. For instance, if you change the kitchen into this size, it will tell you, no, you cannot do it because you're smaller than 3.5 square meters. So, and also it can do the analyzing of the units. How about different parameters is good or bad? And eventually, if you still want CAD, okay, we can download a CAD file with the layers already be managed, and also PSD file with the colored image already be done for you. So very convenient, and I think it's a revolutionary tool for us. It's called Building Creator, and this is our latest let's say product, and also our one of our best products ever. And if you are interested in this one, you can click XCool.ai, and there's an English version of the website, but we don't have it in the English version of the entire website. But everything you are working on it is on this website. So if you are interested, you can go and check it out. Yeah, just you need to log in or sign up with your WeChat or mobile or even email address. We don't have an email address registration before, but if you're outside China, you can use the email address to register. Previously, we only have a mainland China mobile phone allowed, so it's more friendly to everyone else now. So we did the tools, and we are keep working on the tools. But how about real projects, not just plans? We are also trying that. So this is a project very interesting. It's Instatron, and it's all be generated by the machine. And you can see we are not generating just the form itself, but it's fitting to the microclimate of the mountain river side, and also simultaneously it also count on the programs and also the visitors convenience and the circulations, etc. So the machine can do multitasking together and to generate the form. And eventually we got the 5 venues, and those 5 venues we did it with the AI, with the facade, and this is the result. And fortunately, this result we got a bid with a local design institute, and this one got the first prize among 240 something competitors. So it's a really exciting project, and it also brings us a lot of confidence that machine can really do something with us to create more efficient and more reasonable design. And after we won the bid, we found out there's a problem, which is the facade. We used the triangular facade, and we found out there's over 30,000 different triangular facades. And this is not possible for further, let's say, design and construction. So our task is how to reduce the different, this is 30,000 triangular facades panels into as less as possible units. And we actually had asked some of the top tiers of facade consultant, even some architectural technology, let's say, firms. But unfortunately, they can only do 133. That's the minimum they tried. So we think that is not really equally friendly, also not economically friendly to the clients as well. So we thinking, how about we use AI to reduce it? So we did. Here is the times of the generation. Basically, this is the 30 million times. We eventually did 12 components, or 12 types of the different triangular shapes into these facades, replace the previously 136. So reduced 90% of the unstandardized or different shapes. And here are the clustering we're using. Yeah, I can play it again. We use the clustering to make it even more, let's say, equally distributed, and also the gap between the panels can be controlled in a reasonable distance. So eventually, this is 12s. This is really a big, I think this is a big movement of the facade design, because previously, if we use the existing technology, we gonna cost 90% more about customizing all the facade panels. I think 100 or even 100 different facades. For some projects, they think, okay, fine, we can do it, but it's not equally friendly. And this project is called the first EOD project in Instatron, ecology-oriented development. So we have to reduce to the really minimum, and this is the result, and we are happy with it. And I think this is the one of the best in the world already. I didn't see any other similar projects right now with this amount of achievements to the minimumness. Okay, this is all about it. XCool, what we're doing is really empower the design with AI. So thank you. If you have any question, please come to me. Thank you. Bye.
Thank you, Wenyu. That is remarkable. I don't know whether anyone's been following developments in AI, but that's the first time I think that last projects have been shown to the West in that detail. And I think that XCool is transforming the architectural practice in China, and soon it'll come to the West. At the moment, it's based on building codes in China, and it's not accessible yet fully to a Western audience. But eventually, they're going to develop a platform called ABC that will be basically taking over from BIM. BIM will be replaced by this new platform. This is history in the making. So I want to move from Shenzhen in China to Miami in Florida and invite Sarah Pages to present her work. Sarah, just to mention, is a graduate of both SIAC and the Architectural Association MTech program, and she has been teaching at FIU, and I'm delighted to be able to welcome her today. So welcome, Sarah.
Hello, Neil, and hello to everyone. I really blown away with One New project, and I'm really excited to go to her website and play around with the features for sure. Actually, I'm gonna share my screen. Can you see?
Yes.
Can you see one screen, right?
Yes.
Okay. Okay, I'm actually showing my project, which I have done at DDes. So the project called Performance-Based Hybrid Shoreline. This is my doctorate project focusing on computational design, sustainability, material science, and digital fabrication. The project has been collaboration between the CREST, which is the NSF supported center at FIU. My focus is on coastal areas. Our coastal area are under significant distress due to climate change and sea level rise. And extensive corrosion and frequent flooding and depopulation of marine species are only a few of these issues. Most of these problems triggers by severe events such as tropical storm, hurricane, and high tide. To protect coastal line, one of the common and widely used technique is creating a hard infrastructure, which means creating a concrete barrier along the shoreline to protect it from the wave attack. This strategy is causing more harm to our ecosystem by making the coastal area more vulnerable to storm, high tide, and coastal and destroying the coastal habitat. The methodology I'm using it here, it's hybrid infrastructure, which means it's a nature-based solution that integrate nature with gray infrastructure such as riprap and natural elements such as salt marsh, mangrove, and to create a more resilient shoreline. The aim here is not only to protect coastal area from erosion, but also collect sedimentation and filter water, as well as promote biodiversity using natural elements such as mangrove and seagrass. To put this concept and design framework to test, I have selected FIU BBC campus as a project site. The project began with site analysis and the data that it's needed, it's been provided through USGIS, ArcGIS to incorporate into multi-layer map. To create this overall topography, I have used a sine wave equation, which the data was gathered from National Weather Services. And variation of these landscape, it's been created using this algorithm. To occupy the selected topography, I have used this algorithmic definition, which is inspired by rock formation, that it's natural phenomena happens along the shoreline, and it's a volcanic eruption creating this Voronoi pattern, which create this Voronoi pattern modular that gives opportunity to create and self-organize and adapt to the site. Here's the integration of the tile and topography. In this image, illustrate how the nature is integrated with this biotile. And these biotile perform as a nursery for mangrove and seagrass, and also filter stormwater using these retention ponds. Finally, using this methodology, 4 different typology, it's been created, and each one has its own functionality. Starting with biomarine solid tile, data optimization. To optimize these tile, I have used solar data radiation as an input. I increase to increase the thermal comfort for marine habitat in the intertidal zone area by varying the height and creating, maximizing the self-shading on the surface area. And also use this color-coded map for storm surge category 4 to determine the high-risk zones and adjust the biotile height accordingly. Next, I'll be talking about the marine holotile, which actually collects sedimentation. The way the data optimization for this tile, I use the optimization algorithm and using the data collected, water data collected from the site. And the greater the turbidity level of the water, the steeper the slope of these tiles become to collect more sedimentation. And eventually a reduced turbidity level, which means less particle, cleaner water. Here I'm gonna be talking about the material research that I have done. I have conducted research into developing more sustainable concrete mix design. To minimize the minimum ratio, cement ratio, I have replaced volcanic ash and lime powder to reduce the ratio. And also I have looked into olivine, which is a natural mineral that captures CO2 and from the water and also lower the acidity. And I have conducted various laboratory tests like compression strain test as well as leaching tests, and selected material that was fulfilling most of the criteria was Roman olivine. The next goal that we had was having increased biodiversity. To increase biodiversity, I look into various literature study, and I realized that by creating texture on the surface, the marine species can attach to them. And by doing so, they protect as a barrier against weathering and erosion and make the concrete more durable and reduce the maintenance and upkeeping. This process called bioprotection, basically. Here are the biomarine tile category and the macro habitat associated with each typology. The fabrication of these tiles actually to make ununiform Voronoi tile, it's challenging. The goal was to create and develop a formwork that is adaptable and the tile can generate it at the site. In order to test the performance of biotile, I have been working and creating these typology using innovative manufacturing technology. These sample tiles also with different texture has been fabricated and placed along the shoreline to be monitored and see their reaction and effects for accumulation of marine biodiversity. And only by a few months, we can see some macroorganism living on them. Next would be biopod tile. which is a hollow texture ceramic tile with a hole in the center. The cow can house mangrove seeds. To restore a mangrove tree, it's quite of a challenging task. I have studied and see a new novel technique that suggested to maintain juvenile mangrove tree at the nursery prior into transplanting it at the site. The biopod tile are actually made from unglazed ceramic material, which is a non-toxic to our environment. And ceramic pots typically increase air movement to and helps promote the root growth. And to analyze the structural integrity of the proposed infill and structural support, I use finite element ANSYS. The fabrication technology here is additive manufacturing with using ceramic extrusion. The requirement for parameters are to create this texture, to create this pod. It's actually robotic speed, degree of extrusion, and structural support. Next, it's bio-seagrass tile, which is an interlocking planter that allows seagrass to grow and stabilize on the seabed. Data optimization of seagrass. The objective is just to cover solution through examination of innovative case study and also to understand how the seagrass restoration it's been happening in the current severe condition. I used the data collected from through interview question from marine scientists. The comments by interview actually been converted into the pseudocode and visual diagrams. And the code also divided in 3 major themes. This process is iterative and the design intervention evolves after each interview. After this various interviews and iteration, finally a set of star-shaped interlocking with a slight variation in the geometry was created in order to evaluate various interlocking. The construction process, it's relatively straightforward. And creating these cushion-like structure, I use a ball rock fabric and with the mix of infill. In this short video, I'm trying to show how the integration of nature-based solution with this multi-purpose artificial infrastructure create an aesthetical pleasing landscape and provide people with a unique experience with their local environment. And these are the seagrass pods. Oops. I think my screen jumped out. And finally, this is the showing how these performance biotalids being placed and monitored along the shoreline to evaluate their performance and their impact on the shoreline. And if these trials are successful, this methodology can expand and apply in different ecosystem in needs and of protection and restoration. And here's my website. I usually post the update of the project and my contact information. Thank you for watching again. And thank you, Neil.
Thank you, Sarah. It's great to see that. Fabulous work. Let's just put the screen share on again, just a moment quickly. We've actually overrun in terms of timing, but I don't know if there's any quick questions. If there is one, we can maybe have one quickly. But I just wanted to thank the presenters today. I think you got a glimpse of some of the work that's going on in the FIU DDes. It's a program, it's a 2-year program, which is non-residential, therefore lends itself particularly to academics who are in post and who are already doing some research. This, I should say, if you want further information, this is where you can go to. There is full details about the program here. We actually have an application deadline coming up very shortly, in fact, the 15th of February, and that is a few days' time, for anyone starting in August of 2022. And we look forward to welcoming applications for that. I don't know whether we have any questions. This will be uploaded onto our YouTube website, along with which is listed down here. Also, several of the sessions that we've had, or the lectures that we've had over the past year, are also uploaded onto our YouTube library. Anyway, so I would like to thank everyone today. Do we have any questions? If not, we'll wrap things up. But if you do have any questions, you can always direct them to me at FIU. You can find my email online, and also on the site that I mentioned here, where full details about the program are listed. I'm just getting a lot of congratulations on social media. It was a fabulous presentation. Thank you, Aya. Thank you, Matt. Thank you, Wanyu, and thank you, Sarah. I would say also we have another presentation from last year, which you can find in our library by Sumin Ham, who's a professor at SIAC, by Philippe Morel, who's a professor at UCL Bartlett, and Marina Rodriguez das Neves, who is teaching at FIU. So maybe we can wrap things up today, and we look forward to further discussions, further examples of the Doctor of Design, the extraordinary people on the Doctor of Design program. I'm very proud to have such talented individuals on this program. It's only 1 year old, but I think it's already making its impact on the world. So thank you, everyone, today for contributing, and we look forward to further sessions, and we look forward to seeing the results of your research. Thank you. Thank you.
Thank you.
Thanks, Neil. It was a pleasure.
Thank you so much, Neil.
Thank you, Matt. Thank you, Sarah.